Hey there students, welcome to Psych 653 Lab Module 3 where we'll be discussing mediation. So some of my objectives for today is I just want to do a quick explanation as to what mediation is, then we're going to discuss the Barron and Kenny criteria for testing mediation, then we're going to do our classic coding tutorial. So what is mediation? A mediator variable is a variable that helps to explain the relationship between x and y. Essentially, so it's that third variable that's saying, hey, some of the effect of x is going through this mediator variable to y as well. And a mediator relationship occurs when a third variable plays an important role in governing the relationship between the two other variables, so between your x and your y variables. So we can have a full mediation or we can have partial mediation. Full mediation means all of the effect goes from x to m to y, and partial mediation says some of the effect goes from x to m to y, but some of the other effect is also going straight from x to y, essentially. In psychology, we're more likely to run into this partial mediation model rather than a full mediation model. So in mediation, we talk about these paths all the time. We talk about the A path, the B path, the C path, and the C prime path. So the C path I'm going to start off with actually is just where your direct effect from the independent variable to the dependent variable without any mediator present. Whereas we have three more paths down here. And the C prime path is saying, hey, what's the effect of the independent variable to the dependent variable while the mediator variable is present in the model? Additionally, we have the A path, which is saying, hey, what's the effect going from the independent variable to the mediator variable? And our B path, which is saying, what is the effect going from the mediator variable to the dependent variable? And these paths come up time and time again, and we'll be discussing them as well, especially when we're talking about defining this in terms of the Barron and Kenny criteria. So speaking of the Barron and Kenny criteria, here it is. So the Barron and Kenny criteria is essentially this set of criteria that Barron and Kenny came up with to make it so that to determine if it's plausible to even run a mediation model. So there's four different things that you need to meet in order to run a mediation model. You need to first determine that x is related to y. Then you need to show that x is related to m, which is your A path. Then you need to show that y is related to m, which is your B path. And lastly, you need to show that m explains the relationship between x and y, which is your C prime path. And you must meet all of this criteria in order to run a mediation model. So with that, let's go ahead and get started in R. So I'm going to go ahead and open up R. Going to create a new R project. Make sure it's saved in the correct path. Name this module _ 03. And then create that project. All right, I'm going to go ahead and download the data set. So to get to the data set, you go to module 3 lab, and it's the mediate2.csv. And we'll do file, save as, browse, and browse it to that R project file. There we go. Okay, so let's see what we got next in our. Okay, so we're going to go ahead and actually I'm going to go ahead and create a new notebook. I'm going to delete all this unnecessary text. We'll go ahead and name this mediation. Let's go ahead and create our table of contents. There we go. I'll go ahead and save it. I'm going to name this module 3 notebook. Okay, great. Looks like we're ready to go. So the next step that we're going to do is we're going to be loading in our packages. We're going to be installing a new package, which is the mediation package, and then the rest of the packages you should already have. So do hashtag load libraries. Insert new R chunk. So I'm going to go ahead and load up some notes here real quick, if you don't mind. There we go. So first we're going to do install.packages, and the new package is going to be called the mediation package. And then we do library. We're going to go ahead and load up the psych package, library mediation, library DP core, and library tidyverse. Okay, and we should go ahead and let all that run. It's going to take a little bit. Okay, there we go. Okay, looks like it all loaded up. I'm going to go ahead and hashtag out this install packages so it doesn't give us any problems later. I'm going to go ahead and save. Now, there's something that I know normally we don't really look at this wall of text that's displayed when we load our libraries up, but there is actually one thing that I want to explain to you right here, and it's right here. It says the following object is masked from package psych, and it's the mediate object, which is the function called mediate. And what I want to do is explain a new R concept to you. So throughout today's lesson, we're going to be experiencing something called package conflicts. So in short, what that means is that both the psych package and the mediation package have a function called mediate. So you can see how that's a problem, right? R doesn't know which package to call the mediate function from. So therefore, we need to manually tell R which package to call the mediate function from. To do this, we use the package name followed by 2 colons and then the name of the function. So it's going to be package name colon function. So it's going to be psych colon mediate. Every time that we use the mediate function, we need to indicate which package we're determining that it's from. We'll see it more later. It's not that big of a deal, but it's just something that we just need to assess for when we're doing this lesson today. So we'll get to that later, but for now, let's go ahead and read in the mediate2.csv folder or CSV file. I'm gonna go ahead and press play and get rid of all this output here. There we go. Do hashtag import data, insert R. So we're going to name this new object called med. We're going to use our assignment operator, read underscore CSV. It's going to be mediate2.csv. Go ahead and press play. There we go. So just a little thing. This is just a simulated data set essentially that just has some X's and some Y's that I created. And we're going to go ahead and see how this relates. I think every single time x4 is going to be our mediator variable, and we're going to be using x1 and x3 for our other variables. So let's go and see what we're going to do next here. Okay, so what we're going to do is run this in separate analyses. The first analysis that we're going to do is we're going to test the hypothesis that x4 mediates the relationship between x1 and y1. So what I like to do is we're going to first determine the Barron and Kenny criteria based on the determine if this is a plausible mediation model based on the Barron and Kenny criteria. So let's go ahead and do this in steps. So let's go and do hashtag analysis one, and then do hashtag step one, determine if correlations are large enough based on Barron and Kenny criteria. So insert R. I'll go ahead. And so what we're going to be doing is, there it is really just testing if each of these are large enough correlation. So if X to Y is large enough correlation, X to M is a large enough correlation, and Y to M is a large enough correlation. The first thing that we're going to do. So let's go ahead, and what we're going to do is we're going to create a new object called analysis1, which is just going to be a bound version of our med data set. So we do med, comma, we want x1, x4, and y1. Okay. Then we're going to get the correlation of our analysis1 data set. So we go ahead and run that. There we go. I'm going to go ahead and just revert back to the slideshow, but it's the same thing that's on the slideshow here. So we got our relationship between X and Y, which is highlighted in red, which is our C path, and say, yeah, that's a pretty moderately sized correlation. Great, okay. But then we see our, let's go and look at this next one. Then we see that our relationship between our mediator and our Y variable is 0.4105. And you're saying, yeah, that's a pretty strong to moderate relationship. But our relationship between our X variable and our mediator variable is really small. It's 0.0434. So what we're asking ourselves is saying, do we have justification to test the mediation hypothesis based on this information because of the Barron and Kenny criteria? And essentially the answer is straight up no. We don't have any evidence to suggest that we should be testing this mediation model at all, because there's a negligible correlation between our X variable and our M variable, and saying nope. So we don't continue on with the mediation model, and we end it there. So we can go ahead and continue on to analysis 2 now. So analysis 2 says it's going to test a hypothesis that X4 mediates the relationship between X3 and Y1. So we're keeping X4 as our mediator variable, and we're mediating the relationship between X3 and Y1. So first thing we're going to do is do exactly what we did before. So we'll go ahead and copy and paste this. We'll just do this for analysis 2. And we can go ahead and do that. Perfect. So what we'll do is we're going to name this analysis 2. And then we're going to do select. And it's going to be X. Oh, sorry. We indicate our data set, med. Do X3, comma X4, comma Y1. And we do our correlation for analysis 2. Analysis 2. So we'll go ahead and run that. And I'm going to go and revert back to the PowerPoint here so that we can have some clearer information of what's going on. So let's look at all our correlations. So we look at the relationship between X and our Y variable, which is X3 and Y1, and say, yeah, there's a pretty moderately large correlation there. So yes, we're on good tracks with the Barron and Kenny criteria. Then we can go ahead and look at our R and XM relationship between our X and our M variable, which is the one that gave us problems before, and say, hey, look, this is a pretty large correlation now. Okay, we're still on the right track. Then we can go ahead and check the relationship between our mediator variable and our Y variable, which is 0.4105. I'm saying, yeah, that's a moderately large correlation. So we're doing pretty good. So we're saying, yeah, actually, we have evidence to continue testing for mediation hypothesis. However, we have one more test, right? What it is in the Barron and Kenny criteria, we also need to, we've shown that X is related to Y. We've shown that X is related to M, and we showed that Y is related to M through our correlations. Now we need to show that M explains the relationship between X and Y. And to do that, we're going to run a semi-partial correlation and see is if the relationship, if it's a lower relationship than our relationship between our X and our Y variable. So essentially saying, is this correlation going to go down when we introduce the M semi-partial correlation? So go ahead and we say yes, we are able to continue. They all have moderate correlations. What we're going to do now is do step 2 and examine and see. So we'll do hashtag step 2, determine if M explains the relationship between X and Y. Okay. So insert a new R chunk. So what we'll do now, and let me go to here, we're going to be running a semi-partial correlation. So you remember from last semester, our semi-partial correlations, we do SP core test parentheses. We have to indicate our X variable, which is X3 in this. And the way we do that, we have to dig into our data set, med1 X3, comma, what our Y variable is. And our Y variable is med Y1, comma, and we need to indicate our Z variable, which is our mediator variable in this case, which is med X4. So if we run that, what we'll see is we have an estimate of 0.399. And essentially all that we're going to do is we're comparing it to this and saying how much is it lower than our relationship between our X and Y, and saying, yeah, it's 0.11 times lower. Now, Kevin might say that that wasn't a big enough change in the relationship to see if it's appropriate or not. But for the sake of this assignment, I think we're just going to go ahead and say, yeah, this is large enough of a change to determine that we do have evidence via the Barron and Kenny criteria to test for a mediation hypothesis. Okay, so and I give you some information here saying, yes, we compare it to our correlation between X and Y, and we determine that it's 0.11 smaller than it, indicating that the partial mediation is plausible. In other words, there's a portion of the relationship between x and y that involves m, essentially. So we passed our Barron and Kenny criteria steps, so we can go ahead and run the mediation model. And the way that we do that is we use the psych packages mediate function to do that. So this is the part where I indicate that we need to use that package name, which is the psych package, colon, the function name, to say that we are going to be pulling the mediate function from the psych package. Otherwise, it's going to output an error for you. So let's go ahead and do that. There we go. So we're going to do hashtag step 3, run the mediation model via psych colon mediate. Okay. Go and insert the new R chunk. We're going to create a new object called fitmed. Use our assignment operator, and we're going to use the psych colon mediate. So we're using the psych functions mediate, the psych packages mediate function. Then we indicate what our outcome variable is, regressed on our predictor variable, which is x3, plus in parentheses what your mediator variable is. It has to be in parentheses for it to detect that it's a mediator variable, comma, data equals med met. And we do summary fit met. And this is going to produce a lot of output, and on the slideshows I give you a lot of information on what these outputs are. Okay, so go ahead and run that. There we go. So it comes out with 7 different windows, and here I provide you what each of those 7 windows do. So window 1 is essentially the model diagram with all the paths and the coefficients labeled, saying, okay, cool, you have this mediation model and it has all these paths, and here's the coefficients that are associated with it. The second window is just the function call. It's not really that important of one. It'll give you any errors that will be reported in there or any warning messages. Window 3 is your C prime path. Window 4 is your C path. Window 5 is your A path. Window 6 is your B path estimate. And then window 7 is the AB bootstrap results for the indirect effect, saying how much is going from X to Y indirectly, essentially. So how much is being crossed through the mediator is what we're saying. So I went ahead and I labeled these a little bit better for you to kind of indicate where all these numbers are coming from. So for example, first window is the diagram, second window is the function call, third window is your C prime path, and I say, hey, look, this is exactly where your C prime coefficient is. Then I say, here's the C path coefficient, here's the A path coefficient, here's the B path coefficient, and then we have what's the real meat of it. It's the A times B bootstrapped analysis. This is the indirect effect, and this is what we're trying to determine whether it's significant or not. So what we're saying here is that there's evidence of partial mediation. You might be asking, like, well, how do I know that, Neil? Well, you look at these lower and upper confidence intervals, and essentially, if these contain 0, then there's not evidence of partial mediation. However, if the relationship between the two, so 0.04 to 0.07 does not contain 0 in it, therefore there's evidence of partial mediation happening. So we look at those are essentially the bootstrap confidence intervals for the indirect effect. So it's the A path times the B path, essentially. And we look, does the estimate contain 0? And we're saying, no, it does not contain 0. Therefore, we're indicating that X4 partially mediates the relationship between X3 and Y1. And additionally, you can actually calculate the proportion of relation of Y1 on X3 that is mediated by X4 by dividing the indirect effect by the total effect. So our indirect effect is 0.05, and our direct total effect is 0.29, which is equal to 0.1862, which means that 18.6% of the effect is mediated by our X4 variable. Now we can go ahead and we're going to do run this again. We're going to run a mediation model again, but I'm going to show you how to do it through the mediation packages mediate function as well. So what we'll do for that is this one runs a little bit differently than the psych one. The psych mediate function I think is actually ideal. I actually prefer it over the mediate function, but we're going to teach you both ways. But really, you can do everything through the psych mediate function as well. But we're going to show you another way of doing the mediate function through the mediation package. So let's do hashtag mediate. Hold on, let's see here. Let's do, how about this? We'll copy this. Well, actually, sorry, we'll do hashtag step 4, run the mediation model via mediate. So now we're going to be using the mediate function from the mediation package. Go ahead and save. Insert our chunk. So this one runs a little bit differently. There's actually 4 sets of things that you need to do. The first thing you need to do is regress the mediator onto the predictor variable, your main predictor of interest. Then you need to run the full model. Then you need to run the mediate package. So I'll show you how we do that. The first thing we're going to do is do fit with an uppercase M. Then we're going to do the linear regression model where we're going to regress the mediator variable, x4. We're going to regress the mediator variable on our main predictor variable, which is x3 in this case, comma, data equals med. Then we're going to do something called fit y lm. And what we do here is we will just run the entire model. So y1 regressed on x3 plus x4, comma, data equals med. Okay, there we go. And I'm going to go ahead and run that real quick, make sure we don't have any errors. There we go. So we have two, we have the fit M and fit Y that are just 2 linear regression models. The fit M was where we regressed our mediator variable onto our main predictor variable, and then the fit Y is where we just ran the entire model essentially with all of our variables included. Now we're going to create another, we're going to overwrite this, we're going to do fit med. Then we're going to use the mediation, so mediation, mediate function. So we're using the mediate function from the mediation package. And the way that we do this, we do fit M, so our model that was regressing the mediator variable on our predictor variable, comma, fit Y, comma, treat equals, quote, x3. So that's saying what is your main predictor of interest, and our mediator equals, quote, x4. Then we do summary fit med. Okay, so let's detail what just happened here. Okay, so we run 2 regression models and save them into separate objects. The first one is the fit M, where we regress the mediator variable onto our predictor variable, and then fit Y, where we regress our outcome variable on our predictor variable and our mediator variable. No need to indicate anything about whether it's a mediator variable or anything yet. Then we're going to run this new function called we're going to run the mediate function from the mediation package, and we're going to say, hey, get the fit M model and the fit Y model, and I want you to know that the predictor variable is x3 and the mediator variable is x4. So we go ahead and run all that. It takes a little while to run. Give it some time. It's doing a lot of work. And then it gives us this output. And I explained the output here. And I went ahead and I explained everything that's going on here as well. So it gives us 4 different things here. So it gives us the average causal mediated effect, which is the effect of the mediator alone. So this is equivalent to the Windows 7, the psych mediate function. So remember that's 0.05. It's the same as in the psych mediate function. We get the average direct effect, which is your C prime path, equivalent to window 3 in psych mediate. Then you also have the total effect, which is your C path. And then you have the proportion mediated, a variance explained by the mediator, which is the A path times the B path divided by the C path. Okay? And that's really it to mediation that we need to know. So I want to just kind of note out here. So what we did is we ran mediation through two different packages. We did mediation through the psych package, and we did mediation through the mediation package. And that's pretty much it for the mediation unit here. So what I'll have you do is you're going to go to your modules. You're going to do the Module 3 lab, and there's an assignment for you about mediation. And please let me know if you have any questions or anything else through email or the lab time as well. Thank you so much for listening.